All right, so we're going to finish up 1.5 today. And like I just said, we ended up at example 2. That was the last thing we did. So we have a definition. We have a lot of words we're going to define. That's what geometry is all about. Pretty soon here, we're going to start doing a lot of problems where you're actually doing some math stuff, okay? We did a little bit last time. I think that was like the first time we did actual math stuff. But that's what geometry is. It's learning a lot of words, learning a lot of definitions, learning a lot of postulates and theorems and stuff like that. But we're going to put it into practice, though. We're going to put all this stuff into practice, all right? And so same with this thing. Okay, this is called the midpoint. So write that down. This is a very important word. Some words we don't use that often, and I'll probably tell you. You know, here's the word, like skew. We don't really use skew very much, but we learned it. Okay, we know what it is. We don't really use it a lot. Midpoint is one of those words that we use a lot. All right, so what I'm going to do, I'm not going to really write down an official definition. I'm just going to draw you a picture and just kind of explain what midpoint is. So we're going to start off with a line. How do we know that's a line right there? Because what? The two arrows, right? The two arrows. Actually, I'm sorry, let's not do this. Let's do this. Let's put a dot at one end. Anthony, do you need to move? Okay, but did you need to smack him with it? Does that help sharpen it? No? I don't have any pencil sharpeners in here. Again, this is not my room, so I don't know. I don't see any pencil sharpeners. So use a pen to take notes in then. Okay, just don't turn homework into me and pen. All right, so I changed my mind. We're not going to put a line here. What is this thing now? It starts here and it ends here, or it starts here and it ends here. Yes, Alex. It's a line segment, all right? So we're going to start with a line segment. And what we're going to do, actually, if I click on it, I can tell exactly where the middle of this is. See that little blue dot in the middle? I'm going to put a dot right there, okay? Excuse me. So I said in the middle. So where do you think we get that from? The mid, right, the midpoint, in the middle, okay? But technically the definition doesn't really say it's in the middle. They don't use that word, but I'm going to put some letters here. We're going to put an X and a Y on the endpoints of this, and we're going to put an M in the middle. We can use any letter. It doesn't have to be M, but it is. What do you think? Since we're doing the definition, what do you think the M is? It's the what? It's the midpoint, okay? Or you could think of it as, you know, halfway between X and Y, all right, if you want to think of it that way. It's not the official definition, but basically it's saying this. M is the midpoint if this is true. Let me change colors right here. If this is true, if line segment XM is equal to line segment or the measure of, if you want to be really, really picky, I'm not really going to be that picky all year, but the book will say the measure of line segment XM is equal to the measure of line segment MY, okay? I'll probably just say XM is equal to MY. Is that all right? Some teachers wouldn't do that. They would have a fit. You know, no, you got to say the measure of it. We're not going to worry about that too much, okay? You know what I'm talking about. So XM and MY are equal to each other, those two line segments. If they're equal to each other, guess where M is then? If these two line segments are exactly the same, where do you think point M is? It's in the what? It's in the middle, isn't it? Okay, or it's the what? Midpoint, okay? So we're going to call this the midpoint. Do you have a pass for me? All right. Let me show you how we write that these two segments are equal to each other. All right, so I would say this. I would say XM. Now, this is what, again, this is what some teachers would probably flip out on, okay? They probably would not like this at all, but I'm going to. I don't care what they say, all right? So I could just say that XM equals MY, all right? Basically, what that says, Braden, we don't need that. Okay, it's not necessary. All right, this is not, hey, listen, we don't have to, Zion, I'm talking. Okay, we don't need that at all. We don't need any of the comments. All right, if somebody sneezes, if you want to say God bless you or something like that, that's fine. But you don't need to say anything silly. Let's just move on, all right? This is honors. I expect more out of honors than all this goofiness and silliness. All right, so we could just say this, or you could say this, that line segment XM, and this is what a lot of teachers, and you'll probably see this in the book, to tell you the truth. You would say line segment XM is, what's that? An equal sign with a little squiggle on the top. Congruent to, right, line segment MY. All right? This is probably how you'll see it in the book. I would be fine if you just said XM equals MY. All right? Again, if a math teacher is watching this video, they'll probably look at that and like, oh, I can't believe that you're letting them do this, okay? It should be this. And technically, yes, I understand why it's this and not this, but as far as we're concerned, we could go either way. All right, do you understand XM? So the length of XM and the length of MY, they're equal to each other, and that would mean that M is in the midpoint. Okay, enough about midpoints. Let's go to something else. All right, let's go back to the whites, and let's do this. We are going to learn some special angles. We've learned about, oops, what do I want? It's going to go to white. Let's go to white. There we go. All right, so we're going to write down some special angles. You probably heard of these angles a lot, but we are going to talk about them right now. So what if you had an angle that looks, and I think at some point, I think I heard somebody talk about one or two of these angles that we're going to do. This is an angle. An angle is made up of two what? Not lines. Two rays. And they have a point where they come together, they meet, they intersect. What do we call that point? It's got a special name for it. Well, it's the end point of both rays, but as far as the angle is concerned, it's called the vertex, right? Okay, that point right there is called the vertex. Now, I'll tell you what, before I do that, let's, guys, just, I'm thinking, it doesn't mean you have a free chance to just talk and goof around. Just sit and let me think, okay? I think I'm going to do this. I'm going to, let's see if I can get a decent looking protractor. I should have done this earlier. I don't even know if I can download these. Let me get something a little easier. I don't have to sit and figure out how to do this. Let's see what this one looks like. And come on. Are there no pictures of a protractor? Let's do this. Let's just go to images. Let's see if I can see a protractor. Ah, there we go. There's protractors. Let's just use this one, and let's right-click on it and save it. And we'll save it, and then we'll open it. All right, and then let's see. Sorry about this. I think if you're watching this online, you don't see anything that I'm doing. I think you only see my geometry screen. But I'm trying to get a protractor on here. Let's do this. That. We'll do this. We'll go to downloads, and we'll do this. Sorry about that. There we go. That's what I want. All right. All right. So here's the deal. It does ask you to do some stuff with a protractor in here. I actually skipped some of those lessons, but I think it's kind of important to see some of this. So if I had an angle, let's definitely not do this in white because you won't be able to see it. Let's go red. So if I had an angle that started, let's say right here at the 90, all right, and then went straight down. We'll just go to here. Actually, technically, it's supposed to go to there. And then we'll make it go like this. All right, that looks pretty good. I just thought about doing this off the cuff, but there we go. So do you see this angle that I made right here, that red one? I didn't put the arrows on the end. Don't worry about the arrows right now, but you know they're supposed to be rays. we measure angles in a thing called degrees. All right, everybody, you've heard of that before, right? Not the temperature outside, but the angles are measured in degrees. So what you basically did, to find 1 degree, they took one full circle and they broke it up into 360 different even segments or parts to it. Okay, that's what 1 degree is. Okay, it's 360th, 1/360th of an entire circle. That's what 1 degree is. So what is this angle right here? We measure this angle in degrees. If you look at this protractor, what do we have? This is 90 degrees. So actually, I'm going to skip ahead. They do another angle first, but since we're talking about this is 90 degrees, and you show a 90-degree angle by putting a little box at the corner right there at the vertex, okay? Put a little box, that means it's 90 degrees. Do you see the 90? Okay. Along here is 0, all right? See how it goes 10, 9, 8, 7? Right here would be 0 degrees. This would be 90, and this would be how many? There's 170, and you go all the way to 180. Now, that's if I'm going from left to right. This also can go from right to left. You see it? There's the 10. See, there's the 10. If you go way down to here, this could also be what? 0, and then going all the way to here, this would be 180. This would be 90 no matter what, correct? It's just straight up and down. It makes a right angle. Show me your hands. You've seen right angle before, right? Have you seen right angle? Yeah, obviously. And in your other classes, probably in elementary school, they talk about what a right angle is. Okay, so that is a right angle. 90 degrees is a right angle. So let's do another angle. We'll just keep it red. Let's do another angle. Let's say we'll go about right there. It doesn't have to be exactly 30, but what I did right here is I made an angle that's less than 90. Okay? We have a special name for that, and Anthony said it. It's called an acute angle. All right? I'm just going to show you on here, then I'm going to write them down. All right? So now, what if you had an angle that went from, well, actually, this is acute to this right here, okay? So if this was 0, this would be 30 degrees, all right? But what if I did this? What if I went out like that? No, stop. Don't want to hear it. I'm teaching. So watch. From there to there. Do you see that? Okay, this is not a 30-degree angle now, is it? So if I went to here, that would be 90, but then I went bigger than 90, so now you're going to have to use these bigger numbers, right? So this went all the way to what? What would this angle be? 150. So this angle right there is 150. It's bigger than 90 degrees. We call that an obtuse angle, all right? An obtuse. So acute is the small angle. So see this little angle right here? Okay, 30 degree, that's acute. Anything that's less than 90 would be an acute angle. Anything bigger than 90 would be what? Obtuse. If it's equal to 90, it's what? It's a right angle, and we have one more. You could also, let me do this in a different color since we've got a lot of, we'll go this light blue. What if I went from 0 all the way to 180? Right there. So what kind of angle does that form? It forms a what kind of a line? Straight line. Well, actually every line's a straight line, but it forms a straight line, okay? So we give that a name, and we call that a straight angle, all right? So if it's exactly 180 degrees, which basically means they're opposite rays. Remember, we did a definition of opposite rays? So if you got opposite rays, that makes a 180-degree angle. We call it a straight angle. We good on that? Okay, so let's move this. Let's just write the words up here. Okay, so let's go through what we talked about. So I'm just going to sketch these super quick. So this is less than 90, and we call this what? An acute angle. Okay, I'll put the little symbol for angle right there, so we don't have to write out the word angle. Okay, if you had a one that goes straight up and down like this, and you put a little box there. Okay, now it's got to have the box. You cannot just assume that that's a right angle unless it puts the box there. Okay, if they put the box there, that means that it is definitely a right angle, even though it looks a little bit off, doesn't look exactly right. But put the box there, it means it's a right angle. All right, so it's a right angle. All right, another one, it's like this and like this. This is what? Obtuse. It's an obtuse angle. And then we'll just do one. Let's just make a straight line here. Like this. Let's say the vertex is right there. This is still an angle. A lot of people don't look at this as an angle, but it is an angle, all right, because it goes from here all the way to there. Do you see that? All right, this is acute. That's right. This is obtuse. This is a straight angle. Writing all these down, right? Okay. It's really important. We're going to talk about these angles a lot throughout most of the year. We're going to refer to an obtuse, to an acute, to a right. In fact, I believe there's a whole entire chapter just on right angles. Can you imagine? How much more could there be about this, okay? But there's a whole chapter just on right angles, and it goes more than that. But it's basically about right angles. Okay, enough of that. Let's move on. Let's do another definition. We're talking about lines and angles, so here's something about lines. We're going to call this perpendicular. Have you ever heard of that word? Yeah, that's a very common word. Well, perpendicular lines. And we have a symbol for it and all that kind of stuff. All right, so it's basically, I'm not going to write it down, but you can. It's two lines that form a right angle. Two lines, actually they could be segments as well. But anyway, we'll just say two lines, okay? Two lines that form a right angle. So let's say you have a line right there, and let's say you have a line right. We can go through, it doesn't make any difference, right? Because they are lines, right? Perpendicular lines. So they do keep on going. All right, so those, now, do I know right now that they're perpendicular? It says perpendicular lines are lines that form a right angle. Do I know that that's a right angle?
Yeah. No.
Why not?
Oh, no, it doesn't have the box.
Doesn't have the box. Again, you can't make any assumptions about it. You can't just look at that and say, oh yeah, that's a right angle. They're perpendicular. You can't say that because you don't really know. That could be off like 0.00001 degrees, right? And then it's not a right angle, all right? It is because I use the shift key on here. When you make it shift, it keeps it straight this way and it keeps it straight this way. But you don't know just by looking at it. Don't make any assumptions about it. So if there's a little box right there, then you know that it's a right angle. So we got a little symbol. Let's put some letters in here and we'll name these lines. We'll put a point here, point here, point here, and a point here. We'll call this A and B. And we'll call this one C and D. All right, so this is how we would name this. Let me push this up a little bit. We would say that line AB, so write down line AB. How would you write with the symbols and everything? Line AB. You put AB with a what? Little line with the two arrows on the end, okay? So what we're going to do like geometry shorthand. This is kind of like, remember I keep saying geometry is like another language? This is how you write geometry, all right? Instead of writing out words all the time, we're going to write this. This means line AB is perpendicular to line what? I'm not going to do the perpendicular just yet. We'll do it in a second. To CD, all right? Now, it doesn't matter if we call it AB or BA. Not if it's a line. It doesn't make any difference. BC or CD and DC doesn't make any difference. But perpendicular looks like this. It's just, it looks like perpendicular lines, okay? It's just one straight up line, one that comes across the bottom like this. That means perpendicular. So instead of writing out that whole big old word, perpendicular, okay, we write that little symbol, all right? So that's the symbol for perpendicular. We're going to use that quite a bit too. It's very, very common. Pretty simple, isn't it? Yeah, pretty easy. By the way, how many right angles do I have here? Just that one with the box on it? Right, because look, this is a straight angle, isn't it? From there to there. Well, I know, but listen, I'm explaining why we can say that those other are right angles. Because look, this right here is a straight line. It's a line, right? It's got the arrows on the end of it. That's 180 degrees. So if this is 90, what's this have to be? 90. It's got to be 90 because once 180 minus 90, it's 90, right? Same thing here. If this is 90, what's that? That's got to be 90. If that's 90, this has to be 90. So if you only know one of them, you will know that the other three are also 90 degrees, okay? Even though you don't put the little box there. Everybody got it? So you got to know at least one of those has the box there. Then you can say that the rest of them are 90 degrees. We good? Okay, enough of that. That's right. Exactly right. And we're going to learn a lot more about lines that intersect each other Again, we have a whole entire, I don't know if it's the whole chapter, but a huge section where we get lines that intersect each other. We're going to figure out, if you know this angle, you got to find another angle, okay? That's the kind of stuff that we do in here. All right, let's keep going. We already talked about a straight angle. They give you the definition again. I'm not going to do that. I did that earlier. Let's do this. Let's talk about congruent angles. Let's see. Let's do this color. We already know what congruent segments are, right? What about congruent angles? That's angles, right? Instead of writing out the whole word. So let's do this. Let's draw one right here. Like that. Put arrows on the end. And then I'm going to copy that and I'm going to paste it. And then I'm going to rotate it just to show you. It doesn't matter if it's rotated or not. If I can grab onto that. Oh, come on. There we go. All right. So let's see. What if I call this angle X and I call this angle Y? Am I allowed to call this just angle X? I thought I had to use 3 letters for an angle. You do? So I can't just call this angle X? No, I can if what? Okay, it's the endpoint, but if there's no other angles coming out of that endpoint or that vertex, right? This is the only angle that's coming out of point X, isn't it? So I'm allowed to call it angle X. You with me? Okay, we talked about this the other day. This right here, this point is point Y, or we could call this angle Y because there's no other angles coming out of this. Now, if I stuck a third angle like this, if I stuck a third ray on here, I've got 3 angles. I couldn't just call this angle Y. But since there's only one angle, I can call it just those letters. All right, enough of that. Let's keep going. What if I told you how many degrees this was? I don't know. That looks like 40 degrees. I'll just make it up, okay? So if that angle is 40 degrees, and let's say that this, now I copied and pasted, so guess what this angle is going to be? It's going to be exactly the same. Even though I rotated it, did it change the angle at all that it made? No, not at all. Okay, it changed the direction that those rays are going, but it didn't change the measure of the angle. So if this is 40 degrees and this is 40 degrees, guess what? They are what? No, they are, follow my lead. What did I just underline? I'm giving you a big old hint. They're congruent angles, all right? They're not 80 degrees. I didn't say anything about adding them up. So how would we write this? How would I write that those 2 angles are congruent? I would say angle what? What did I call this angle? Angle X is congruent to what?
Angle Y.
Angle Y, all right? So this is how I would say that, all right? So we say that they're congruent to each other because they're equal in measure. The measure, 40 degrees, we measured the angle, okay? Well, I just guessed what it was. I didn't really measure it, but they would be equal to each other. All right, let's do another one. And again, I've taught this before, so I know you're going to see this kind of stuff. So here's another word that you're going to see. And we will, it's not that we use it all the time, but there is a part that we're going to do later on that we use this stuff. You've seen a situation like this before, right? These are rays. How many angles do we have here? We have 3, all right? And so let's do this. M, K, and P. No, I'm using whatever's in my notes, all right? So I'm just going straight from my notes. What I want you to do is I want you to look at these 2 angles. I want you to look, let's do this in a different color. Let's take a look at this little angle right here and then this angle right here. Now watch. Here's something I didn't talk about. I should have talked about it here. Do you see how this has one arc and this has one arc? That means if you have 2 angles and this one has one arc and this one has one arc, even if I didn't know they were 40, pretend I didn't even say they were 40 degrees. If this had one arc and this had one arc, what do you think you could say about those 2 angles? They would be what? Congruent to each other. Not lines. They're what? Right here. Look. They're angles. You just say the first thing. You got to think first before you speak. Okay? You didn't? Okay, I'm sorry. I thought you did. So these are congruent angles. Right here, now that one definitely looks skinnier than that one, doesn't it? even though that arc is a lot bigger than that, does that mean those two angles are equal to each other? Well, if that's what I wrote, if I wrote one arc and one arc, that means that they would be equal to each other, but they're not. So if I wanted to show that one angle is a different measurement than the other angle, I would put one arc for one angle, then I'd put two arcs for another angle. You see the difference? What does that mean? That it doesn't tell you exactly how many degrees it is, right? It doesn't tell you the measure of the angle, but it does say that this angle is one measure. This has to be a different measure than this one because one has two arcs, one has one arc. If they both had one arc, then what would be true about the two angles? They would be what? They would be congruent to each other. That's right, all right? So, but these angles, they're kind of next to each other. Do you see that? Do you see how they're next to each other? The formal definition would be this. Well, let's give you the actual word here. So if I say something is next to each other, and this is a word that students don't usually use very often. Nate, get your head up, please. I want your eyes up here looking at the screen, okay? Here's a word that students don't use very often, but if you listen for it, you'll hear it on TV, you'll hear it on movies, you'll hear old people like me say this every once in a while. Like if we said that Jack and Juliana are sitting next to each other, that's what we would usually say. But you could say that they are adjacent to each other. You ever hear that? Because they are what? Next to each other, okay? Your next door neighbor is adjacent to your house, okay? His house is adjacent to your house. You follow me? So let's take a look at these two angles. Look at this angle right here and this angle right here. What are they to each other? They're adjacent to each other, okay? And that's a word that you'll hear every once in a while. It's not super famous or whatever. It just means they're next to each other. Did I spell that right? Yeah. All right, so they would be adjacent angles. Now, there's no special symbol for adjacent. Okay, you would just say, how would we name this angle with one arc right here? We would name it what? MNK. Very good. So we would say that angle MNK, right, we don't have any special symbol, so we just say adjacent. I'll just put ADJ, is that all right? Is adjacent to angle what? KNP. Now, technically, the definition says this. It says, it's kind of wordy, but it says coplanar angles. What does that mean, coplanar? They're in the same what? Plane, okay? So you got two angles that are in the same plane with a common side, okay? Do you have two angles here with a common side? And what is the common side? Well, a side has to be a what? A side of an angle has to be what kind of a shape or what kind of a figure? It's got to be a ray. Very good. Okay? A side of an angle has to be a ray. So don't just say point K. What side is in common with this angle and this angle? NK, ray NK. All right? So it's ray NK. So ray NK is in common. So it's got to do two things. It has to have a common side. So in order to be adjacent, all right, it has to have a common side. And now here's the weird one. No common interior points. I'll just shorthand some of this. Okay? No common interior points. We talked the other day about what interior exterior points are. Okay? So for instance, if I put a point right here, in order for these two angles to be adjacent, if I put a point here, it cannot also be in the other angle. Would you agree? Is there any way that this point right here could be in both of these angles? No. Is there any point inside this skinny angle right here that could also be in this angle? No, there's not. Okay? So that means if it goes by two of these criteria, if it has a common side, which it does, and there's no common interior points, then guess what they are? They are adjacent angles. But as far as we're concerned, we just say they're next to each other. But there might be a question like this. They might say yes or no, or true or false, that angle MNP, do you see MNP? It's that whole big angle. And look at MNK. Are they adjacent? Are MNP and MNK, are they adjacent to each other? Well, do they have a common side? MNK, MNP. What's the common side? Look, this big one right here. Say it. Right. Well, it's technically NM because it's a ray. It's got to start here. So NM is a common side, right, for the whole big angle and this little skinny one up here. But look at number 2. What if I put a point here? This point lies in the big angle, and it also lies in this little skinny angle. Is that no common interior points? No, that means it does have a common interior point. That means it is not adjacent. Okay, so this big angle right here and this skinny little angle right here are not adjacent to each other. We good? All right. That's right. It's inside. It's not just next to it. Okay? Everybody got it? That'd be like saying your bedroom is adjacent to your house. It's not. It's inside the house. It shares some of the same things in the house, doesn't it? Okay? But it's not adjacent to it. It's not next to it. It's in it. Yeah.
So what if it didn't have a point?
Well, it means any place in space has a point. Okay? It's just not necessarily labeled. So if I just take a point inside of here, every angle has infinite number of points inside of it. Okay? We just labeled it. Is all we did. We just showed where that point was. Every single angle has an infinite number of points in it. Okay? We just said that this particular point. Is it in both of these? No. Does it have a common side? Yes. That means this angle and this angle are adjacent. All right, we got to keep going. We're almost done. Let's do this. We'll keep that same color just for the sake of time. And we'll do this. And then we'll do another one like this. You writing this down? You should be furiously writing this stuff down. All right, let's do this. M, N. Looks like we're using the same letters, doesn't it? This thing is called the angle addition postulate. Let's write that down real quick. The angle addition postulate. Basically, it's saying this. I'm running out of time, so I'm going to go kind of quick on this. Basically, it's saying this. If I took angle MNK, and I added it, okay, that's the first time we talked about adding angles. But if I added it to angle KNP, that will equal what? So what am I doing? I'm taking this angle, which is at MNK, and I'm taking this angle right here, which is KNP. What would they combine to be? Say it. MNP. Very good. Angle MNP. That's basically what the angle addition postulate, okay, is. It just means those are equal to each other. For instance, if this was 50 degrees and this was 20 degrees, what's this whole big angle going to be right there? 70 degrees. You got it? All right. So here's an example, and we'll be done. I got like a minute left. So I'm still going to assign something, so don't leave. Nope. I don't have time. I've got to do this. And then this. It's not. I didn't put the arrows on here, but don't worry about that. So now we're going to do some math on here. They name this angle 1, and they name this one angle 2. All right? And it says find angle 2. Oh, they tell you that these angles are equal to each other. That angle 1 is equal to angle 2. All right? This is what they tell you. Let me finish. I can't take a question right now. I'm sorry, because I don't have any time. Angle 1 equals angle 2. So if I wanted to, I could put a little arc here. I could put a little arc there to show that they're equal to each other. And they also tell you, just hang on for a second. I'm going to be done real quick. They say that angle 1 is 55 degrees. So they ask you, what is angle BAD? This is pretty easy. So what is angle BAD equal to? Well, angle 1 is 55 degrees, right? And that means angle 1 and 2 are the same. Braden, go ahead. Very good. So that's 55 degrees. Angle addition postulate means, what is angle BAD? What's this whole big angle right there? Then you just add them up, and you add 55 and 55. It's 110 degrees. Here is your homework. So it's section 1.5, Now I skip around a little bit on this, so write it down. Well, it's actually on the paper I gave you. If you came in late, I have a paper for you, but I'm going to write it down just in case somebody needs to look at YouTube. So it's pages 27 to 29, and you're doing 1 to 14, 21 to 28. Is this what I gave you? And then also 34 to 35. So I skip around quite a bit. That's your homework right there. Have fun.